So starting off here in bell work, these things should look fairly familiar. It's what we've done the last couple days. Given tangent of theta is that and secant is that, find cosecant. Okay, so anytime we're trying to find a trig function, we're going to start off with x, y, and r. Based off of what they gave me here, Eli, what do I know? So y is 5 and x is 2 based off of this. Good. You said secant is less than 0. What does secant mean? R over x. So that means r over x is negative. I don't care about an r because an r can't be negative. So you went ahead and said x was negative? Yeah. Okay, good. So x was negative. How did you say that the y was negative? Good. Tangent's positive. And so Eli went ahead and said if tangent's positive, that the only way that tangent can be positive is if x and y have the same sign. They're either both positive or both negative. And since here he knew that x was negative, that means his y had to be negative as well. Good job. Once we've done that, we got to find our r. You didn't have to do it in this order. Sometimes I would do the signs at the end, but that's fine. Pythagorean theorem, 2 squared plus 5 squared equals r squared. 4 plus 25, 29, square root it is r. Plus or minus square root of 29? Positive. Radius is always positive, so square root of 29. Once I've done that, I'm doing cosecant. Cosecant means r over y. So r over y. There's my answer. Questions on my first one? Second one says cosecant of theta is 4/3. Tangent less than 0. Find secant. We're starting off with x, y, r. Abby, what do we know? Yep. R over y, so she knows her r is 4, her y is 3. Good. Tangent's less than 0. So tangent's less than 0. Megan K, what does tangent less than 0 tell us? X and y, if they're both negative, would that give me a negative thing? Good. X and y are different signs. I keep doing this in a funky order. I apologize for that. But x and y are in different signs. Good. We've got 3 and 4. We've got to find x, and Megan interpreted that to be x and y are different signs. Cool. Let's do Pythagorean theorem to find our missing one. Boom, equals 4 squared. So 16 and 9 and x squared. X squared is 7. So x is plus or minus root 7. So what do we think? Is it going to be a positive or a negative radical 7? Negative, because we said that it has to be different signs, and we know that y is positive, because cosecant couldn't be positive if your y was negative. It's not possible. So x has to be a negative root 7. Everybody go to there? Then we just put it together. Okay, what am I going to have to do here for secant? Good. R over x. So your r is 4 and your x is negative root 7. We like that answer? Nah, we got to multiply by root 7. So negative 4 radical 7 all over 7. Boom, doom, boom. There's my answer. Questions there? Uno mas. Secant is less than 0. Cotangent 0. Less than 0. Name that quadrant. Show me with your fingers. Which quadrant did we end up in? Getting some 2s, some 4s. Let's see which one it is. If we are doing secant is less than 0. Aaron H., what does secant mean? Do we care about r if we're talking about signs? R is always positive. I'm less than 0, so I'm negative. Which direction, Aaron, do you need to go to make your x value negative? To the left. So it's either one of those two. Good. Then we're doing cotangent is less than 0. Megan, see if cotangent is less than 0. What's that tell me? X over y, and they're negative, so it has to be different signs. Which two quadrants are x and y different signs? 2 and 4. They're both positive there. They're both negative there, so it's got to be 2 and 4. Which one do they match? 2. Questions on that one? Wonderful. All right, so again, today we are focused on properties of trigonometric functions. First of all, that's the best word in the English language. Trigonometric. Got to add a little flavor to it, but it's a good word. Okay, properties of trigonometric functions. We're going to fill in some different information, just a lot of different things that are going to help us out here. Okay, so first thing we're going to do is fill in this chart. We're doing sine at some angle. Point, where is 0 radians located? Over here, if we're doing sine, sine means y. Good answer. Sine means y. What's my y value going to be right here? 0. Okay, the next one is pi over 2. Point, where's pi over 2 located? Up here. If I'm doing sine up here at pi over 2, what's sine of pi over 2 going to be? 1. And then it's sine at pi. So we're over here, and then we're up here. Now we're over here. What is sine at pi going to be? 0. Finish the rest of that chart with your neighbor. Go. Here's, we're doing a lot here. Show me with your fingers. What did you get for sine at 3 pi over 2? That's down here. So we got a -1. What about 2 pi? Show me your fingers. What did you get for 2 pi? We're to 0 because we're back here to the start. What about 5 pi over 2? 5 pi over 2 is 1 because we're back there at the top. Here we go again. Cosine. 0. Show it to me. Pi over 2. Pi. 3 pi over 2. 2 pi. The other one. Good. Now tangent gets a little funky. Show me the fingers. What'd you get for tangent at 0? Tangent at 0 should get you 0 because it's y over x. 0 over 1. You already did the work, right? It's y over x. It's 0 over 1. It's 0. And so if I'm doing tangent, it's 1 over 0. That is undefined. This one is y over x. So 0 over -1. That gets me 0. -1 over 0. That gets me undefined. 0 over 1. That gets me 0. 1 over 0. That gets me undefined. That told me the first thing that we just learned. That if I want to talk about tangent of an angle, it is the same thing as sine over cosine, because sine means y and cosine means x. Tangent is simply sine over cosine. See where we're coming up with that? It's y over x. Good. That's the first learning moment of the day. Okay. Now let's look at domain and range. If we are dealing with the domain of sine, so think about sine. Think about what would happen if I were to continue. We stopped at 5 pi over 2, but what if we would have gone to 3 pi and then 7 pi over 2 and then 4 pi and then what value can I not plug into sine? All real numbers. It's just going to keep spinning around forever and ever and ever. I can plug in anything I want for sine. What about cosine? All real numbers. That pattern's just going to keep repeating, and I didn't have any errors. It means what angle could I find the x values for? So basically it's saying name an angle. Can you find an x value at that angle? Yeah, you can. Name any angle. You can name a y value for that angle, and it would give me a value. Okay, it's talking about basically start at 0 and spin around the circle as many times as you want. You're never going to be able to stop moving your finger and then say, hey, I can't figure out what that y value is. Does that kind of make sense? That's weird. What about tangent? Is tangent all real numbers? No. We're going to start with all real numbers, but it's not all real numbers. It's all real numbers, but x cannot be what? Can x be 0? All right, when I say x, the angle can't be what? Can't be 90 degrees, pi over 2. It can't be 270, which is 3 pi over 2. It can't be 5 pi over 2. It can't be 7 pi over 2. It couldn't be 9 pi over 2, and so on. Every one of those spots is undefined. So we need to write that somehow. And there's a couple different ways of writing it. I'm going to write it like this. It can't be n. The angle cannot be n pi over 2, where n is what? What is n going to represent if it can't be n pi over 2? Odd integer. Because every odd integer, whether it's 1 pi over 2 or 3 pi over 2 or 5 pi over 2, those are the ones where it's going to be undefined. Yes, ma'am. Yeah, you'd have to say what it is. Yeah, you could do it that way. You could also do it like theta cannot be pi over 2 plus n pi, where n is just an integer, because it would be like pi over 2, and then if you add a pi, that'd be 3 pi over 2. You add a pi, you get 5 pi over 2. It doesn't. There's lots of different ways of doing it, but you got to come up with a consistent way of saying that. What about the range of sine? What values, what output did I get for sine? In -1 until 1. My answer was between -1 and 1. When you think of that y, don't think of it as y as in like sine means y. Think of it as like the output. Think of it as what did I get back when I got an answer? I got an answer between -1 and 1. What about cosine? Where was my answer living for cosine? What did I get as an output? -1 to 1. And range here, you can't really pull range from what we did. We did not get enough. Tangent is more exciting than just 0 undefined, 0 undefined, 0 undefined. There's stuff happening in between. The range is going to be all real numbers. We will do that in the second part of this chapter. Okay, the second part of this chapter, we will talk about the graphs of these things. For right now, just believe me. We good there? Let's get to this. So this is somewhat interesting in terms of what's happening. Okay, considering the unit circle and maybe testing a few different angles, what is the relationship between sine of negative theta and sine of theta? Okay, sine of negative theta and sine of theta. Let's talk about that for a second. So sine of negative theta and sine of theta. Okay, look up here. Look at that unit circle. Pick your favorite angle. Don't pick, for the sake of what we're doing, don't pick 0 or pi over 2 or pi that. Pick your favorite angle besides those. All right, you got it? Tell your neighbor, what did you get for sine? Now you are good. So whatever you picked. So let's say I picked 45 degrees. What would my sine be at 45 degrees? Root 2 over 2. Now I'm going to go to sine of the negative angle. So I picked 45. I'm going to go to where negative 45 lives. Okay. If you struggle with that, remember, like if you picked negative 220, or if you picked 225 and you're trying to go to negative 225, it's just like 360 minus that. So it'd be 135. Okay. So go to the negative angle of what you started with and look at the sine of that thing. Tell your neighbor what happened. Here was 45 degrees. Here is negative 45 degrees. I was radical 2 over 2. Now I am negative radical 2 over 2. You picked a different angle than me, or maybe you picked the same one. Were your findings the same? Yes. Whatever you started with, it just became the negative version of that when you did the negative angle. Why is that true? What happens when you do a negative angle on the unit circle? Where was your angle in comparison to the original angle? It's on the opposite, right? You take any number, 120, if you did the opposite, it's 240. Okay? If I picked 300, if you did the opposite, it was 60. Because 300 plus 60 gets me 360, right? It's two angles that go together to get me 360 there. Okay? That's the concept. Okay? That it's going to flip me over the x-axis. Well, what is true about all of my y values in the top half of the circle compared to all the y values on the bottom half of the circle? They're all the same, right? You just flip over. If you were to flip over that x-axis, all of my y values would match up with the exact same thing. The only difference is to get to this one, I've got to go up. And to get to that one, I got to go down. That one would be positive. That would be negative. That would be positive. That would be negative, and so on. That is why when I do the sign of that, it just changes the sign. Okay, so this is an even-odd identity. We don't really need to write anything here. I need to adjust that. This is just where we're supposed to be thinking. But these are even and odd identities. An identity is just a statement that is always true. No matter what the theta is, it's always going to be true. And what we just learned was that if I do sine of the negative angle, it's the same thing as the negative version of whatever you started with. It's negative of whatever you started with. Same thing would be true with cosecant. If I have cosecant of a negative angle, it would be the same thing as negative cosecant of that starting angle that you had. Use your brain. Now that we've done sine, think about that unit circle now with cosine and with tangent. What happens when you do that same process with cosine and with tangent? Take a second or a minute or two with your neighbor and try and figure your way through that. Go. So we figured it out with sine. Now we're trying to figure out with cosine. So what happens if I took cosine of a regular angle and the cosine of the negative angle? What did we discover? Somebody raise your hand and tell me. What did you discover when we did cosine of those two things? Megan? The sign stays the same. Everybody somewhat agree with that concept? Because it's true. Okay, pick an angle. All right, let's pick 30 degrees this time. If I'm doing cosine, cosine is radical 3 over 2. Cosine of 30 degrees is a radical 3 over 2. What is cosine of negative 30? Well, that would be this guy. And if I'm doing cosine, guess what? It's the same. Why is it like that for cosine? The x doesn't change. If I go from this angle to that angle, it doesn't affect how much I went left and right. I'm still going right that much. Because if I flip around half the circle, it's just going to the right if I reflect over the x-axis. Okay, if I went to this angle, it reflects down to that one. Well, the x values are the same because I'm just going to the left. Okay, that doesn't change anything. All of these are positive, all of these are negative. So when I flip them over, it's just going to be the same. So let's write that out. So what we just learned was that cosine of a negative angle is exactly the same as cosine of the original angle. Okay, same thing with secant. Secant of a negative angle would be exactly the same as secant of the original angle. Now let's do tangent. Okay, same process. Now let's do tangent. Matthew, pick us an angle here. You want to make it hard. All right, cool. That's a jerk move. You know that, right? 150 degrees. If we have to do tangent at 150, what is that going to get you? Yeah, you're the one who picked it. 1 over negative radical 3. Let's just leave it like that. He's a mean person. But he picked 150. We good? That's 150. What would be the negative angle of 150? 210. Because it's the one that when you add it gets me 360, right? And so it's this guy right here. If you wanted to do tangent here, what is tangent of this guy going to be? 1 over square root of 3, positive or negative? Positive, because I have two negative signs. How did these two things differ from each other? We changed the signs, because if you were to flip down, this is going to get you a negative answer. That's going to get you positive. This is going to get you positive. If I flip down, that is going to get you negative. Okay, it's just understanding what happens when you flip over the line. So tangent would be negative tangent of that angle. Negative cotangent of that angle. That's the idea. Let's put that into practice. This is something we will use occasionally. We're not going to use it all the time, but it's a good idea of what's going on. Even odd properties. Find the exact value of negative sine of negative 2 pi over 3. There are two ways you could do this problem. Okay? The first way you could do this is say, all right, negative 2 pi over 3. Which angle on this unit circle is the same thing as negative 2 pi over 3? 4 pi over 3, because 2 pi over 3 is how much I go to that way. Negative 2 pi over 3 would be the same thing but starting the other direction. So it is the same thing as 4 pi over 3. It is the same thing. Sine of negative 2 pi over 3. Oh, yeah, that's the same thing as negative 4 pi over 3. I'm helping us out because I'm looking at a unit circle. But what is sine of 4 pi over 3 going to get me? Negative radical 3 over 2. That is my answer. That is one way of getting that answer, and it's a perfectly great way of getting that answer. But there's another way we could do it. Okay? We are doing the sine of a negative angle. Sine of a negative angle. We just said right here that sine of a negative angle is the exact same thing as a negative sine of that angle. So it's the same thing as negative sine of what? 2 pi over 3. So sine of 2 pi over 3. What's my value going to be? Square root of 3 over 2. And it's negative of that. So it's negative square root of 3 over 2. We got the same thing both ways. Neither of them is better or worse than the other. Whatever way makes you happiest, go with it. Okay, but understand how that even odd identity applied there. Questions on the first one? Do the second one. Do the same thing with your neighbor. Find both ways of doing it. Here we go. Cosine of negative 225. That is the same thing as cosine of what angle, Lydia? What is the same thing as negative 225? That is the same thing as 135 degrees, because, again, it's like 360 minus 225. Oh, yeah, it's 135. So cosine of 135, I'm in the second quadrant. It's 135. It is going to get you radical 2 all over 2. Then we're doing cosine of negative 225. That is the same thing, using my even odd identities. What do we do with cosine if I have a negative angle? The same. We just basically forget about the angle. Cosine of 225. I'm in the third quadrant, so my... Oh, I screwed this up. I meant to have a negative sign there. I'm a dummy. I was in the second quadrant, sorry. Cosine of 225. I'm in the third quadrant. I'm right down here. It is going to be the same thing, negative radical 2 over 2. Both things get me the same answer. It's just a matter of understanding where they came from. Questions with that? Let's learn something else that you'll hate me for. Flip it over. Let's apply the Pythagorean theorem to right triangles formed on a unit circle. Okay, these are called Pythagorean identities. We're going to use this all the time. You've got to be good at this. Okay, Pythagorean theorem. And we'll use it more later on. We're not going to use it a lot this chapter. The next chapter, we use it all the time. Pythagorean theorem. Everybody agree with me? Pythagorean theorem is x squared plus y squared is r squared. Watch what I write. Tell me if it's the same. Is that the same? Yeah, it's the same. Okay. Y squared plus x squared equals r squared. You can write that, yeah. Okay, that's the same. Now, think about what you know about math. If I take this equation and I divide everything by the same thing, does that change the problem? No. So if I divided everything by r squared, we agree that that doesn't change anything? Think about what that means, okay? To get to this spot on my circle, I've got to do that. I've got to do this, and I've got to do that. This is obviously my radius. This is my x. This is my y. Well, we have talked about this over and over again. Which trig function is the same thing as x? Cosine. What trig function is the same thing as y? Sine. And we can find that by dividing by r. Look at what I just wrote down. Y squared over r squared. Well, what is y over r? That is just sine. Okay, that is just sine of theta squared. Okay, look at this. I'm going to write it, but you don't write this first part. Sine of theta squared. You will never see it written like that. You will never see sine of theta squared like that. When we want to square it, they put, and it's weird, but they put the square after the sine, before the theta. Not quite sure why they do it. It makes it a little bit cleaner because you don't have to put parentheses, but that's where they put the square. What is the same thing as x over r squared? That would be cosine squared. And what's the same thing as my radius squared if I'm on a unit circle and my radius is 1? Equals 1. That is a true statement. We just learned that sine squared plus r squared equals 1 is true because it's based off of Pythagorean theorem. Okay, it's a true statement. You can plug in any angle here for theta. You could plug in 60 degrees or 90 degrees or anything else. And if you take the sine and you square it plus the cosine and you square it, you're going to get 1. Let's do it again. Stay with me here. So we're starting with the same thing. Y squared plus x squared equals r squared. The first time through, we divided everything by r squared. Now let's divide everything by y squared. What is y squared over y squared going to get me? That's 1 plus, what is x squared over y squared the same as? That is cotangent squared. And then I've got r squared over y squared. That is cosecant, because r over y. Oh yeah, that's cosecant squared. That is a true statement. No matter what theta I plug in here, I can plug in 30 degrees. You're always going to make that a true statement. Okay? 1 plus cotangent squared equals cosecant squared. Again, we just started with Pythagorean theorem and we divided by something. Okay, let's do one last one. Guess what I'm going to divide by this time? Let's divide by x squared. What happens if I take y squared divided by x squared? Y squared divided by x squared is the same thing as tangent squared. X squared over x squared. That is just 1. And r squared over x squared, that is secant squared. That's a true statement. No matter what, that is always going to be true. Okay? And again, we are going to do this more later on. This is not as big as a deal in this chapter as it is in the next. But that is where we're headed. All 3 of those statements are true. You need to have that memorized, but all you really need to do is take Pythagorean theorem and divide by different stuff, and you can figure out what you need. So let's look at example 1. Cosine of theta is negative 3/5. Okay? We lie in the second quadrant, find the exact value of the remaining trig functions. 95% of the time, actually 99% of the time, I would tell you to do this problem by doing x, y, and r, and do it just like we did in Bell. That would make total sense. But you could do it with Pythagorean identities and get the same answer. They gave me cosine. So which Pythagorean identity do we know that starts with cosine, or has cosine in it? The first one, sine squared theta plus cosine squared theta equals 1. It's just Pythagorean theorem. It's not anything more than that. We don't know what sine squared is, so we're going to leave it. We know what cosine of theta is. Instead of cosine of theta, I'm going to plug in what cosine of theta is, which is negative 3/5 squared, is equal to 1. What happens when I take negative 3/5 and I square it? What's that going to get me? 9/25 plus sine squared is all equal to 1. Okay, I could say it's equal to 25/25 if you want to. I'm going to get sine by itself, so I'm going to subtract 9/25. So I get sine squared theta equals 16/25, because I just moved that 9/25 over. I want to get theta by itself, so what else do I need to do? Square root, sine of theta is equal to the square root of 16 over 25. What is the square root of 16 over 25 going to get me? 4/5. Now, technically it's plus or minus, so I need to use this other information to help me out. I'm in quadrant 2, so what does that tell me if I'm in quadrant 2? X is negative, but my y is positive, so it'd be a positive 4/5. You can do it that way. Would I suggest it? No, you can do it the other way too, and it works perfectly fine and maybe a little less confusing, but you can. And once I've got sine, cosecant would be easy. What would cosecant be if sine is 4/5? 5/4, you flip it. We already know what cosine is. They told it to me at the beginning. Cosine of theta is negative 3/5. So if I got that one, secant is easy. It's negative 5/3. And if I've got sine and cosine, then tangent should be easy, because what is tangent the same as? Sine over cosine. Y over x. Sine over cosine. So what would I get here if I did sine over cosine? Negative 4/3. 4 over negative 3. It's negative 4/3. And if I've got tangent, then I've got cotangent, because it's just the reciprocal of that. It's nothing wrong with it. I don't know if it's the best way to do it, but you could figure it out because everything's related to each other. Okay? Try the same thing on the next one. They gave you tangent. Try to use a Pythagorean identity, and all I want you to find is secant. Just tell me secant on that last one. Here we go. So we decided which trig function we started with. Since it had tangent in it, we picked the one that had tangent. Okay, again, to figure out tangent, all you would have to do is divide by x squared with everything, and it figures out what I want. I plug in tangent, it's 1/2 squared plus 1 equals secant squared. What is 1/2 squared going to get me? 1/4, because I'm squaring the 1, I'm squaring the 2. Since I'm adding to something with 1/4, I'm going to make 1 4/4. The secant squared theta. Add these two together, so 1/4 plus 4/4, 5/4. Then I'm going to square root. Square root. The square root of 5 is the square root of 5, but the square root of 4 is 2. Is it going to be positive or negative? Let's play the quadrant game. Here's what I know. If I'm playing the quadrant game, my tangent is a positive 1/2. If my tangent is positive, which two quadrants could I live in? Where they're the same sign. Tangent is positive, means they're the same sign. And sine is negative, means my y is negative. So if my y is negative and I know they're the same sign, I have to live in quadrant 3. And if I live in quadrant 3, secant has to be negative. Some